Uh, Actually, we have discussed some of the questions of this tube. This is the 600 questions tube. But I am going to discuss some of the questions of the same tube. I will recall your memory as well as I am going to discuss some new questions also, not only the old questions. It means I am going to discuss about 2 questions per section. That's what I am going to do, right? For example, I discussed the first 2 questions under this linear motion section. Can you understand? Under the linear motion equation sections, I just discussed only 2 questions, 1 and 2. Right? So like that, I'm going to select 2 questions per section and I'm going to discuss few questions. It will be a big help for you to recall your memory because and the other thing, we are at the end of this lesson. Right? And you can identify whether this lesson is easy or difficult for you. Right? Somebody unmute the mic and read the first question there. Somebody please unmute the mic and read the first question. Hello, any volunteers? I think you remember the link, right? You should talk to me. Is the video clear or not? First of all, please tell me.
Clear, sir.
Yeah, okay. Please read the question for me, dear.
A vehicle starts to move at rest along a straight path with a constant acceleration of 2 meters per second, 2 meters per square second. Find its velocity and displacement after 30 seconds.
Very good. Find the velocity after 30 seconds. Vehicle starts to move at rest. It means initial velocity is 0. Straight line path with a constant acceleration of 2. Find the velocity after 30 seconds. Right? Let's give a try. You can see the board. It's not much clear. Okay. Look at board. Look at board. So I'm going to discuss few of the questions of 600 questions tube. 600 questions tube. Okay, right. Question number 1. So there is a vehicle. It starts to move at rest. It means initial velocity is 0. Initial velocity is 0. It travels along a straight line path with a constant acceleration of a equals 2 meter per square seconds. Then question asks us to find its velocity after 30 seconds. After 30 seconds. So what will be the velocity of this vehicle after 30 seconds? That's what they have asked. Even we can find the displacement. To find the velocity after 30 seconds, we can apply the equation to this direction. That is v equals u plus at. Right? So initial velocity is 0, acceleration is 2, time taken is 30. So then 2 into 30 is 60. So it means after 30 seconds, velocity is 60 meter per second. So it's a huge velocity. Just draw the figure and write it down. Sometimes you may have answered this question earlier, but I recommend you to rewrite it. This will recall your memory. This will take you back to the track of the paper class. So start. Wait. Right. Then how do we find the displacement? I don't know whether it is asking the question or not, but I would like to find the displacement. So how do you find the displacement here? To find the displacement, we may apply this equation. Why do I draw an arrow always? Why do I draw an arrow always? Because we are working with vectors. Final velocity, it's a vector. Initial velocity, it's a vector. Acceleration is the vector. So when we work with vectors, we must indicate the direction. So object is moving to my right hand side direction. Object is moving to the right hand side. So therefore, I apply all the equation into the right hand side. Object is moving into the right hand side. So I apply my equation into the right hand side. So that's the reason, right? So let me apply the equation is equal ut plus half a square. We have proved all these equations in our theory class, right? Is equal u, initial velocity is 0, time taken is 30, plus half, acceleration is 2, time taken is 30, and square of that. So we will get 0 into anything 0, 2 and 2 cancelled out, only 30 square will be there. Square of 30 is 900. So the displacement of the object for 30 seconds is 900. Right? Displacement of this vehicle for 30 seconds is 900 meters. Completely clear? We are just discussing some of the questions given in our 600 questions tube. I'm going to select 2 questions per subheading, and I'm going to discuss some questions to recall your memory about the mechanics lesson, because we have reached to the end of linear motion section, right? So we are going to start circular and rotational motion in mechanics lesson. That's the reason, right? Complete there. Right now, let's go to the second question. Let's go to the second question. Let me show you the question here. Right. Somebody unmute the mic and read question number 2. We discuss only first two. After that, we go for another section. Somebody please quickly unmute the mic and read the first two questions. The second question number 2 here.
An object starts to move at rest, obtains a velocity of 30 meters per second within 10 seconds. Find its acceleration and displacement.
Right. So what is the initial velocity here?
Zero.
Zero. Or starts to move at rest mean initial velocity is zero. Yes, very good. Then obtain a velocity of 30 meter per second in 10 seconds. So final velocity will be 30 meter per second and time taken to achieve that velocity is 10 seconds. Find its acceleration and displacement, right? So as usual, we just draw a figure and mark the given data. Question number 2 of the 600 questions dude. We are just discussing only few of the selected questions, right? Then there is the object. I'll draw a vehicle, that's much easier for me. Starting velocity is 0. It travels along a straight line path and its final velocity is 30 meter per second. 30 meter per second. To achieve this much of a velocity, the vehicle takes a time of 10 seconds. Am I right there? The vehicle takes a time of 10 seconds. That's what it says. So time taken for this is 10 seconds. Displacement we don't know. The acceleration we don't know. Right. Just draw this figure here. Please draw this figure, then only it is easy for you to understand. Right? Once we draw a figure and once we mark the given data, it's easy for us to understand. Okay? We draw figures and we mark the given data, then it's easy for us to understand the things. Start there. right? We just want to find the acceleration. Acceleration can easily be found. We just want to apply the equation v equals u plus a. V equals u plus a. So final velocity is given as 30. Initial velocity is 0. Acceleration is simple a. We don't know actually what the acceleration is. Time taken 10 seconds. So it means 30 equals a into 10. If I take 10 to this side, 30 divided by 10 equals 8. So a equals 0, 0 cancelled out 3 meter per square seconds. 3 meter per square seconds. Got it? Who got this answer before I explain it? Who got this answer? So raise your hands up here. Okay. Good. Right. Then how do you find the displacement here? How do you find the displacement? So this is a paper class, so I'm not going to, because, and we have already discussed these questions, so I'm not going to revise the theory. I'm just giving you a help. To find the displacement, I just apply the equation S equal ut plus half at squared. Right? Initial velocity is 0, time taken 10. Plus half acceleration, we have found it as 3. Time taken is 10. We should get the square of 10. Time taken is 10 and we should get the square of 10. So then 0 into anything 0 plus half into 3 square of 10. Square of 10 is 100. So you can do something like this. 0 plus 3, 100 divided by 2. 100 divided by 2 is 50. 50 times 3 is 150 meters. So what is the displacement of this object here? 150 meters. Who got this answer here? Lamai, who got? Please raise your hands up there. Right. So many of you have obtained the answer. It means you have not forgotten mechanics. You have not forgotten mechanics. I'm so happy. So let's select another section. Let's select another section and go for another question. Right? Let's select one more question. So. Let me show you the next section and the next question. Okay. Right, so this is the second section of the tube. This is the second section of the tube. Right, so here I just answer question number 11 and 12 only. It means I just answer 2 questions per section. I just want to recall your memory. I just want to recall your memory. That's what. Right. The question number 11 asks the following objects are moving along a smooth horizontal surface. Find their accelerations. The following objects are moving along a smooth horizontal surface. Find their accelerations. Let's give a try here. The mass of the first object is 10 kilogram. The force acting on it is 20 Newton. So we just apply F equals ma. The force is 20, mass is 10, acceleration is simple a. By cross multiplication, I can take 10 to the side of 20. So the equation will be simple a only we will there, 10 will be at this side, 20 divided by 10, 20 divided by 10 is 2. So we got the answer as 2 equals a, but we should write one more step. We should write a equals 2 meter per square seconds. Please complete this here. This is the answer for question number 11, Roman number 1. Quick. Question number 11, Roman number 1. Complete here quick. Is video clear here? Can you see the board clearly, Lamai?
Yes, sir.
Right, thank you, dear. Right, shall we go to the second question here? I'll give the answer here. Shall we go to Roman number 2? Right, how many forces are acting on the second object? How many forces? 2 forces. What are the directions of the forces? Are they acting into the same direction or opposite direction?
Same direction.
Then when we say F equals ma, in the equation F equals ma, F is the resultant force. For this case, resultant force is summation of the 2 forces. As forces are acting in the same direction, the resultant force is the summation of the 2 forces. We should indicate it like that. Mass of the object is 12, acceleration is simple a. Can you do the rest and find acceleration here? Right? So you should remember that in this F equals ma equation, F means the resultant force. F is the resultant force. Got it? F is the resultant force. Do not forget it. Right? Please write here. So here the resultant force is the summation of the 2 forces because they are acting in the same direction. As they are acting in the same direction in this equation, resultant force is the summation of the 2 forces. So 4 plus 2 is 6 equals 12 times 8. So in the next step, we can take this multiplication 12 into the other side as division 12, right? So it will be 6 divided by 12. 6 divided by 12 equals simple A. Got it? So 6 divided by 12 is half. So it's very much clear. 6 divided by 6 is 1. 12 divided by 6 is 2. So A equals half. 1 equals 1 divided by 2. 1 divided by 2 means, what's the answer here? Half means, Lamai? 1/2 is 0. 10 divided by 2 is by 0.5 meter per square second. So this is the answer. Is it clear for clear all of you, dear? Right. So please remember that whenever they have given the equation F equals ma, it means the resultant force. F means the resultant force. In Roman number 2, both forces are acting in the same direction. Therefore, the resultant force is the summation of the two forces. The resultant force is the summation of the two forces. Okay, dear? Right. Shall we go to question number 3? Who wants more time to write the things, dear? Tamal? Right. Let's go to question number 3. Right. For the Roman number 3, for Roman number 3, let me apply the equation again if equals NB. Right. Now, somebody under the mic can tell me the number of forces acting on the third objective.
2, sir.
Two forces. Are they acting in the same direction or opposite direction?
Opposite direction.
Opposite direction, sir.
Then what is the resultant force here?
20 Newton minus 60 Newton, sir.
Yeah, minus 60. Bigger force minus, bigger force minus smaller force. So what is the resultant force? Very good. 20 minus 16. 20 minus 16 is the resultant force. Mass is 4. Acceleration A. So 20 minus 16 is 4 equals 4 times A. 4 times A. So 4 and 4 cancel out. 4 divided by 4 is 1. Therefore, what is the acceleration? Somebody under the mic can take me here.
1 meters per square second, sir.
1 meter per square second. Very good. Please write them all. Very good here. 1 meter per square seconds. Completed here. Right. I have discussed question number 11. I want to go to question number 12. Once I discuss question number 12, I will go to another section of the same tube and I just discuss 2 questions. So I just want to recall your memory. That's all. That's what I want. Right. Who wants more time to write with answers? Anybody in the class? May I go to question number 12 now? Is the time enough for you to write? Okay, then I'll go to question number 12. I'll erase them all. If you want to take a screenshot, I'll erase them all and I'll go to question number 12. Right. Somebody unmute the mic and read question number 12. Start. Somebody unmute the mic and read. You said an object of mass 2 kilogram moving on the rough. What is the meaning of rough here?
It has frictional force.
It has frictional force. That's the meaning. Rough horizontal surface mean friction forces are acting on the object. That's the meaning. Right. With the constant acceleration of 0.2 meter per square second. So, by a horizontal force of 6 Newton. So, what are the given data here? Surface is rough. Surface is rough means there should be friction forces. There should be friction forces. So, first of all, I should mark the friction force. The friction force acting on the object, I have marked into this station. In addition to the friction force, weight, the gravitation attraction force, which is known as weight of the object acting downward. In addition to the gravitation attraction force, there must be normal reaction force, which is given by the surface. Right? So let me use a different color pen and draw it. The reaction force given by the surface to the object. Right? Like this. And what is the mass of the object here? 4 kilograms. Please draw this figure. Please draw this figure quickly. So this is the friction force. So I use Fr. Fr Newton is the friction force acting on the object. Can you? I think you are able to see the board clearly, right? Then the weight of the object. Then the weight of the object should also be marked. Weight of the object is mg. mg Newton. Sometimes it is called weight of the object, sometimes, but actually it is the gravitation attraction force given by the Earth. We call it as the weight, but the best term is the gravitation attraction force given by the Earth. Then let me mark the normal reaction force. The normal reaction force. Normally it is indicated as capital R Newton. Capital R Newton. So please mark them here. Quick. Draw the figure and mark the forces acting on the object. And they have given us the acceleration also. Acceleration of the object is given as 0.2 meter per square seconds. This is also given. Mark them all here. There are two methods to find friction force. There are two methods to find friction force. Here acceleration is known. So as acceleration is known, I'll use the equation F equals ma. Look at board here. I'll use the equation F equals ma because acceleration is given, acceleration is known. Now somebody unmute the mic and tell me, I'm going to apply F equals ma along the horizontal direction. F equal ma along the horizontal direction. That's the point. Along the horizontal direction. Right. Somebody tell me how many forces are acting along the horizontal direction here.
Two forces.
Two forces. Are they acting in the same direction? No, opposite directions.
Opposite direction.
Opposite directions, sir.
Very good. They are acting in the opposite direction. They are the resultant force. F is the resultant force. Now resultant force is 6 minus Fr. Fr is the friction force. Equals mass of the object is given as 2 kilograms. Acceleration is given in the equation as 0.2. Acceleration is given as 0.2. Can you do the rest of the simplification and tell me the answer here? And send your answers to Zoom chat. Please do the rest of the simplification. Send your answers to Zoom chat. From this equation, you can find Fr. Fr means friction force. Send me the value of friction force. Start. It's so simple, right? So I'm not going to do anything to 6. Actually, we can't do anything to 6. And we cannot do anything to Fr equals 4 into 0.2. 4 times 2, 8. But there should be a decimal place. So it is 0.8. 0.8. Right? So in next step, I'll take this 0.8 to the other side. Plus 0.8 comes to the other side as minus 0.8. Minus Fr goes to the other side as plus Fr. 6 minus 0.8 means 5.2 equals Fr. But we never keep an answer like this. We should keep the answer as Fr, friction force, equals 5.2. Then we should write the unit. So we should always keep the answers in this format. Fr equals something. We do not write a number equals Fr. That's something. That's really complete here. Who got this answer? Fr equal 5.2 Newton. Lamai. Right. What's the other equation? What's the other equation that can be used to find friction force. We have learned another equation to find the friction force. What is it?
Friction force equal to mu r.
Friction force equal mu r. Mu is a constant. What's the name of the constant? What's the name of the constant mu? It is called coefficient of friction. What is it called here? Lamai?
Coefficient of friction, sir.
Very good, very good. Coefficient of friction. Here, look at board here. Who gives this mg force? Who gives this simple mg force? Let's say this object is kept on a table. Let's think this object is kept on a table like this. Table is kept on the earth. Who gives this simple mg force?
Earth, sir.
Earth, very good. Simple mg force is given by the earth. Who gives capital R force here?
The surface.
The surface of the table. The surface of the table. If R force is larger than mg force, what will happen to the object? Will it be moved or not? Sorry, dear?
The object moves upwards, sir.
Very good. If capital R force is larger than mg, the object will be moved up. If mg force is larger than R, Lamai, what will happen?
The object moves downwards.
The object moves downward. If mg force is larger than R, it will be moved downward. If R and mg are equal,
The object will be at rest.
it will be at rest. So object will not be moved upward, object is not moving downward, it is moving only along the horizontal direction. Therefore, R and mg forces should be the same. Star pointer right. Star pointer right. There is no motion along the vertical direction. Star pointer right. There is no motion along the vertical direction. Therefore, there is no motion along the vertical direction. Therefore, upward force should be equal to the downward force. There is no vertical motion. Full stop. Therefore, upward force should be equal to the downward force. Right. So leave a line and write. Then upward force is R, downward force is mg. So R equals mg. So mg is 4 kilogram, g is 10. 4 times 10 is 40 Newton. Got it here? So we have found the normal reaction force. Complete it here. We have found the normal reaction force. Normal reaction force is given by the surface on which the object is kept. Okay? The normal reaction force is given by the surface on which the object is kept. Okay, dear? Capital R is the normal reaction force. Capital R is the normal reaction force which is given by the surface on which the object is kept. Capital R is the normal reaction force given by the surface on which the object is kept. Kept, K-E-P-T, kept. Right now, I'm going to use the second equation for the friction force. Friction force equals mu r. I use the letter English letter U to indicate mu because I don't have any other way. I don't have Greek letters in this keyboard, right? So we have already found that friction force is 5.2 Newton. Mu we don't know. R is 40. Right. So by using this equation, we can find the mu. I have indicated English letter U, but it's, you should use the Greek letter mu for it. Can you find the value of mu and send me your answers to the group chat here? Zoom chat. So if you take 40 to this side, let me take 40 to this side. So multiplication 40 come to this side as division 40. So 5.2 divided by 40. 5.2 divided by 40 equals mu. Got it? So what can we do here? How do we simplify this? The easiest method is this. Look at board here. I can divide 5 by 4. 5 divided by 4 is 1 point. 5 divided by 4 is 4. 5 minus 4 is 1 remains. Then 12 divided by 4 is 3. So if I divide 5.2 by 4, answer is 1.3. If I divide 40 by 4, answer is 40 divided by 4 is 10. Sorry. So what have I done here? I have divided both 5.2 and 40 by 4. Okay. Then 1.3 divided by 10 is 0.13. So mu is known as the coefficient of friction. We have found it answer as 0.13. What's the unit of mu here? Somebody unmute the mic and tell me what is the unit of mu?
No units.
No units.
No.
Very good. No units. No units. Somebody please unmute the mic and read the question once again. Question number 12. Somebody please unmute the mic and read one more time.
An object of mass 4 kg is moved on a rough horizontal surface with constant acceleration of 0.2 meters second minus 2 by the horizontal force of 6 Newton.
Thank you, dear. Thank you very much. An object of mass 4 kilogram is moved on a rough horizontal surface with a constant acceleration of 0.2 meter per square seconds by a horizontal force of 6 Newton. So what are things that they have asked? As I remember, they have asked us to find the coefficient of friction. And as I remember the things that they have asked. Yeah, the coefficient of friction. Find the coefficient of friction and find the friction force acting on the object and the coefficient of friction. So what are things that they have asked? I think you can barely read this question. Find the friction force acting on the object and the coefficient of friction. Okay, dear? Right. So the complete answer to the question is here. If you want, please take a screenshot. If you want any more time to write the answer, please take a screenshot. The complete answer is here. Okay, shall we go to question number 13 also? I think it will be a help if I discuss question number 13 because sometimes you may have forgotten about the tension forces in a string. May I discuss question number 13 also, or are you okay with it? No answers. Right. I'll list everything and I'll go to question number 13. Right. But I'm not going to discuss more than question number 13. I'll go to another section just after I discuss question number 13. Right. I use the letter U for the instead of mu because I do not have the letter mu in my keyboard. As I cannot type mu, I use the English letter U. So if you are really upset with it, just make it mu by drawing a line like this. If you want, okay, those things are no problem, right? Right. Let's go to question number 13. Right. Somebody unmute the mic and read question number 13. Start there. Read all the things, all the questions, including Roman numbers.
Two objects are connected by a light inextensible string and they are moved on a smooth horizontal surface by a horizontal force as shown in the figure. Roman 1. Find the acceleration of the system. Roman 2. Draw the free force diagram of the object and the string. Roman number 3. What are the tension forces acting at the end of the string?
Right. Two objects are, thank you, Buddha. Two objects are connected by a light inextensible string and they are moved on a smooth horizontal surface by a horizontal force as shown in the following figure. Find the acceleration of the system. That is a very simple question. We can find the acceleration at once. Look at board here. So to the system, look at board. To the entire system, to the system, I'll apply F equals MA. So here F is resultant force. F means resultant force equals here M is resultant mass and A is acceleration. So those are the things that you should understand. Right. So here, what are the things here? What are the terms? Right. If you apply Fe, if you say you are applying F equals Ma to the system, the meaning of F is resultant force, the meaning of M is resultant mass, and so on. Resultant force. What is the resultant force here? The total force acting on the object here. Lamai. The only force acting on both objects, 18 Newton. Therefore, the resultant force is 18 Newton. Equals, what is the resultant mass there? Acceleration, we don't know. Somebody
9 kilograms.
mic can tell me resultant mass.
9 kilogram.
9 kilogram mass of the first object plus mass of the second object. That is the resultant mass. Please write all the things as I have written and find the acceleration simple A star. No need to draw a figure, right? No need to draw a figure. Figure is there. Just write this equation and find the acceleration here quick. And send your answers to the Zoom chat. Send me your answers of simple A to the Zoom chat. Right, many of you have sent me the correct answer. I'm so happy with your answers. So 18 equals 3 plus 6 is 9 into simple A. So if I take 9 to the other side, if I take 9 to the other side, it will be 18 divided by 9. 18 divided by 9. Multiplication 9 goes to the other side as division 9. So 18 divided by 9. 18 divided by 9 is 2. So it means simple A. It means simple A equals half. 9, 18 divided by 9 is 2. 2 meter per square seconds. Who got this answer, Lamai? Who got this answer? Please raise your hands up. Everybody, please raise hands up if you have obtained this answer. Right, very good. Please take a screenshot if you want any more time to write these things. Please take a screenshot because I am going to go to Roman number 2. I am going to go to Roman number 2. So therefore, if you want any more time to draw the things, please take a screenshot. Right. Roman number 2. Draw the free force diagrams of the object and the spring. Free force diagrams. I would like to use whiteboard to explain free force diagrams. Right. I would like to use my normal whiteboard. If you want, you can take a screenshot of this one. This is the second friction of 600 friction tube. I'm going to erase and I'm going to use my normal whiteboard to explain free force diagrams. Look at what free force diagrams, free body diagrams, same meaning, right? Let's move. Okay, look at board. So what are the masses that they have connected? 3 kilogram and 6 kilogram. There are two objects. There are two objects of 6 kilogram and 3 kilogram. This is 3. And 6 kilogram. Right? They are kept on a smooth horizontal surface. It means no friction forces. A force is applied on the 6 kilogram, that is 18 Newton. They are connected by a spring, light, smooth, and a horizontal spring. We found that all these objects moving with an acceleration of 2 meters per square seconds. Right. Now I'm going to draw the free body diagrams. First of all, I have drawn the normal figure given in the question, and now I'm going to draw the free force diagrams. Right. My question is, listen, I'm going to ask few questions before I draw this figure. Right. This 6 kg object is moving to my right hand side. Why is this object moving to right hand side? Somebody tell me why it is moving into the right hand side.
Because of the 18 Newton force.
Very good. Because of the 18 Newton force. So there must be a force for any object to be moved. For any object to be moved, there must be a force. This 6 kg object is moving into the right hand side because of the 18 Newton force. So if I draw this 6 kg object, if I draw this 6 kg object, it is moving into the right hand side because of this 18 Newton force. That's why it is moving into the right hand side with an acceleration of 2 meters per square seconds. My second question is, if I consider this string, if I consider the string, right? If I consider the string, why it is moving to the right hand side? Same logic. For any object to be moved with an acceleration, there must be a force. The string is moving to my right hand side with an acceleration. Therefore, there must be a force acting on the string. The string is connected to the 6 kg object. The string is connected to 6 kg object. Therefore, when the 6 kg object is moving right hand side, it pulls the string. It pulls the string. So let me mark the force acting on the pulling force as F1. Who gives this F1 Newton force here? F1 Newton force is given by 6 kg object to the string. Right? Now somebody tell me Newton's third law of motion. Somebody tell me Newton's third law of motion.
Every action has an equal and opposite reaction.
Every action has equal and opposite reaction. Very good. So F1 force is given by 6 kg object to the string. Why? String and 6 kg object are connected together. So when the 6 kg object is moving to the right hand side, it pulls the string with the force of F1. Every action has equal and opposite reaction. Therefore, when 6 kg object gives a force of F1 Newton to the string should give equal and opposite reaction force. Equal and opposite reaction force. So I'll instead of using F1, let me use that letter T1. So T1 is the force given by the 6 kg object to the string. Then the object gives equal and opposite force of, let me mark it as F1. Let me explain again. The string and 6 kg object are connected together. Therefore, when 6 kg object is moving to one direction, 6 kg object pulls the string by a force of T1. Because of that T1 force, the string is moving into the right hand side. So T1 force is given by 6 kg object to the string. Right? Every action has equal and opposite reaction. Therefore, when 6 kg object gives a force of T1, the string should give equal and opposite force. Then this T1 and F1 are called action reaction forces. Action reaction forces. Action reaction forces. So please do not forget action reaction forces. So my next question is about this 3 kg object, right? So who gives a force to this 3 kg object to be moved? Because even the 3 kg object moving to right hand side with an acceleration of 2 meters per square seconds. For this 3 kg object to be moved into the right hand side with an acceleration, there must be a force. Who gives that force?
The string.
The string. As the string is connected to the 3 kg object, when the string is moving right hand side, it pulls 3 kg object. It pulls 3 kg object by a force of F2 Newton. By a force of F2 Newton. Who gives this F2 Newton force? The string. Why? The string is connected to the 3 kg object. String is connected to the 3 kg object. So once the string is moving to a certain direction, it pulls the object with it. So the string pulls the object by a force of F2 Newton. Then 3 kg object moved right hand side with this acceleration because of this F2 Newton force. Again, somebody unmute the mic and tell me Newton's third law of motion. Somebody in the class.
Every reaction has an equal
So
and
every
opposite
action has
reaction.
an equal and opposite reaction.
Every action has equal and opposite reaction. So when the string gives a force of F2 Newton to the object should give equal and opposite force to the string. Am I right? When the string gives a force of F2 Newton to the object, right? The object should give equal and opposite reaction force to the string. So let me mark that force as T2. Let me mark that force as T2. So they are again called action reaction forces. Right, got it? In addition to these forces, I just marked two more forces. The weight of the 6 kg object acting downward as m1g, which is given by gravitation traction force of the earth, and the surface, the force given by the surface, which is known as normal reaction force. Let me mark it as R1. So here the gravitational attraction force acting this object is into G Newton, and the force given by the surface is R2 Newton. Force given by the surface is R2 Newton. It is known as normal reaction force. So I have marked all the forces acting on all the objects. This kind of diagrams are said to be free force diagrams and free body diagrams. You can use any terms. The string is a light string, no mass. When an object does not have a mass, the weight of that object is 0. Therefore, I have not marked the weight of the string as m3g. We do not mark it because string is said to be light. It means no mass. Please draw both figures and try to memorize. So I have completely taught these things in my theory class. This is the paid class. So if you have not learned these things, just send me a message to my WhatsApp after the class, but not now. Right, draw them all here quick. Right, I think time is enough for you to draw this figure. Right, so these T1 and T2 are known as tension forces acting on the spring. These T1 and T2 are known as tension forces acting on the spring. So as action and reaction forces are equal, F1 equal T1, F2 equal T2. So the first thing is that action force equals reaction force. They are equal in magnitude. Therefore, action and reaction forces are equal. So therefore, F1 equals T1 and F2 equals T2. F1 equals T1 and F2 equals T2. Got it? So if I found the value of F2, that is equal to T2. If I found the value of F1, it means that is T1. They are equal, right? So look at board. I'm going to apply F equals MA only to 3 kg object. Only to 3 kg object, I'll apply F equals MA. The only force acting on the 3 kg object is F2. The only force acting on the 3 kg object is F2 along the horizontal direction. Therefore, F2 equal mass of the object is 3, acceleration is 2. So it means F2 equals 6 Newton. So if F2 is 6 Newton, then we can write in that therefore T2 is also 6 Newton. Got it? Write them all here. If you have any doubts, send me a message to Zoom chat or just unmute the mic and ask. Right, now we want to find this T1. Actually, the string does not have a mass. The string is massless. When a string is massless, the tension forces should be the same. T1 and T2 will be equal. T1 and T2 will be equal. But let me prove that. Let me prove it that T1 and T2 are equal. So I'll do something like this. I'll apply, look at board, only to 6 kg object. Only to 6 kg object. To this direction, I apply F equals MA equation. Somebody unmute the mic and tell me the number of forces acting on 6 kg object along the horizontal direction. Lamai, someone?
2.
2.
2 forces, very good, 2 forces. So F is the resultant force. 2 horizontal forces are acting on the object. Therefore, the resultant horizontal force is, as they are acting into the opposite direction, 18 minus F1. They are acting into the opposite direction. Therefore, difference of the forces is the resultant. Mass of the object is 6. Acceleration of the object is 2. So 18 minus F1 equals 6 times 2 is 12. So I'll take plus 12 this side as minus 12. Minus F1 goes to the other side as plus F1. So 18 minus 12 is 6. So it means F1 is 6 Newton. Therefore, T1 should also be 6 Newton. So T1 and T2 are the tension forces at the ends of the string. As there is no mass, as the string is massless, T1 and T2 are equal. Both are 6 Newton. Both are 6 Newton. Complete the note. Write them all here. Start. If you have any doubt, just unmute the mic and ask. I can help you. Okay, I think you have written them all. Shall we go to next question here, Lamai? So I would like to go to the next section of the same tute. I think we have answered successfully all the question number 30. Right, let me show you. So I'm going to select some questions from this tute to recall your memory. So we were discussing the second section, Newton's laws of motion. Now I'm going to go to the third section of the tute. Here, right. All are Newton's laws of motion questions. Number 18. Now I would like to discuss question number 19. Somebody unmute the mic and read question number 19 here, quick. Somebody please unmute the mic and read question number 19.
A bullet of mass 0.4 kilogram is fired towards a stationary wood block. The wood block is kept on a rough horizontal surface. The mass of the block is 0.6 kilogram. After the collision, the bullet gets embedded in the block and they move as a single object. The coefficient of friction between the block and the horizontal surface is 0.4. Roman number 1. Calculate the velocity of the block with the bullet just after the collision. Roman number 2. Find the friction force acting on the block after the collision.
A bullet of mass 0.4 kilogram is fired towards a stationary wood block. The wood block